Welcome to my video. I am Dr. Amuda Devi. I am going to talk about simple perceptron learning under the course Deep Learning. So before going to perceptron learning, I want to just explore what is basic neuron. Mehulla and Pitts, these are the two persons developed single neuron that is based on their understanding of biological neurons. Here in this case, n number of inputs are given and one output is received. The input is also binary, output is also binary. So to map this n number of inputs to output, there are two functions used. One is g, another one is f. Here in this case, input x1 to xn, if any value is 1 means the particular value is presented in the input. If the value is 0 means the particular value is absent in the input. The function of g is just to summate the values. It calculates x1 plus x2 plus x3 up to xn. The summated value is given to activation function f. This f calculates the output to 0 or 1 based on some value called theta. Theta is the threshold parameter. If the summated value is above or equal to theta means the answer will be 1. Otherwise the answer will be 0. So this logic is called threshold logic and the parameter theta is called thresholding parameter. So next we'll see Boolean gates. As the basic Medulla-Pitts neurons are binary value, binary output neurons, this can be easily used for designing basic Boolean gates. We will see the simple Boolean OR and simple Boolean AND. We know that as per the truth table of OR, if any input is 1 means the answer will be 1. So that the theta can be designed as 1. So here we are having n number of inputs x1, x2 up to xn. So our function g is just summates. For example, if any one x1 plus x2 up to xn is 1 means automatically we will get more than 1 or more. So it satisfies our theta. So automatically we will get 1. If all the values are 0 means the summation will be 0. So we will get the answer as 0. Coming to the Boolean AND, we know that all the values should be 1. If you are adding x1 plus x2 up to xn, the total value should be n. Then only it will give the answer as 1. So that the theta value is designed as n. So based on our Boolean gate, we should just set the theta value. In the Boolean OR, theta value is 1 is enough, because any one input gives the answer 1. In case of Boolean AND, all the values should be 1. So if you are having n number of inputs, the theta should be n. Now we will see the simple perceptron. It is similar to basic previous thing. In the previous Boolean gates and all, we just summated the input values. There is no concept called weighted sum. Here in this case, for each input from x1 to xn, we are having weights, associated weights. Along with that, see at the top, we are having one constant value multiplied with weight. This is called bias. In some kind of perceptron, the bias concept is not also available. So it is optional only. If we want bias, we can add it. Otherwise, we can remove it. We are having n number of inputs. For each and every input, we are having the corresponding weight. x1, w1, x2, w2, xn minus 1, wn minus 1, xn, wn. Like that, for each and every input, we are having the corresponding weight. So after that, this weighted sum will be calculated. So this is the function of g. The function g, as per the previous one, it will calculate the summated weight. Every time all xi will be multiplied with the corresponding wi, and we are having additionally bias will be added. After this calculation of weighted sum, this value will be given to the activation function. This is represented as a step function f here. It calculates the actual output. So in this example, the sigmoidal function is used. There are so many activation functions are available. In this case, sigmoidal is used, and here the theta is also used. In the threshold logic, theta is used as 0. If the answer is after activation function, if the answer is above the 0 means positive value means the answer is 1. If the negative value means answer is 0. So the possibility is input values are given and weighted sum is calculated, and after that activation function is applied. Finally, we apply the threshold logic. So up to previous cases, we learned how to calculate the output. We didn't concentrate about how to reduce the error, how to update the weight. That we didn't concentrate. Now we should concentrate how to get the desired output and how to adjust the weights. So our input is having the combination of input and output. And sometimes initial weight is given. Initial weight is given means we have to take the value as it is. If the value is not given means we have to take either 0 or small numbers. So if you are having n number of inputs means n number of weights should be available. So that much values we should initialize if the weight is not given. First we have to take the first example and we have to calculate the output. How we can calculate the output? We have to summate that based on the weight multiplied by input, and we have to apply the activation function. We will get the output value. That output value should be compared with the desired output value, that is the target value. If not matching means we have to update the weights. The output updation rule we will see now. So this is the rule for updation of output. So every time weight should be updated as actual output along with the small variation in the weight. So how to calculate the small variation means this formula, learning rate multiplied by loss value. This is nothing but target minus output. Target is nothing but what value we should get, that is called desired value. Output means nothing but what value we received for the current input multiplied with input. So this is the formula. These are the two formulas we should remember. So weight should be updated with actual weight plus small changes in the weight. The change will be learning rate minus learning rate multiplied with loss function multiplied with the input value. Here the same thing is given, and this learning rate will be ranges from 0.0 to 1.0. If you are taking higher value means the convergence will be very fast, but we cannot get the exact weight value. But if the value is taken as very less, for example 0.1 means it will move slowly to the output. So based on that we have to fix the learning rate. Sometimes for some conditions if the learning rate is given means we have to take as it is. The learning rate will be constant for all the inputs. The perceptron learning problem. So what is the input given? The combination of input and output is given. So input and the desired output is given. That is called input and output. And initial weight is given means we can take it as it is. If not given means we should take randomly. So in this case one possible input is given. So 1, 2, 3, 4. So 4 number of input is given, and in x2 is another set, again 4 number of input values are given. So next weight is given. So again there should be 4 values. The first value belongs to first data, second value belongs to second data, third one belongs to third data, fourth one belongs to fourth data. So we are having 2 set of input x1 and x2. So definitely we must have 2 target values. D1. D1 is for data set x1, D2 is for data set x2. So now we have to apply the perceptron learning algorithm. We have to update the weight. So we are taking the first example. So what is our x1? First data set 1, 2, minus 1, 2. So 4 inputs are here. Correspondingly 4 weights are here. Here 0.2 belongs to the input 1, 0.1 belongs to the input 2, 1 belongs to the input value minus 1, 0.3 belongs to the input value 2. So our desired value is 1. So first step is we have to calculate the weighted sum. How to calculate the weighted sum? The value multiplied with the input value multiplied with the weight value. So 1 into 0.2. The first one multiplied with 0.2 plus second input multiplied with the second weight 0.2. Then third value minus 1 multiplied with 1. Then fourth value 2 multiplied with the weight value 0.3. So this is given here. So finally we will get the value. So this is called weighted sum. Next, after calculating this one, we have to apply the activation function. See, for calculating this one, we are getting the answer as 1. So now it is called weighted sum. After this weighted sum, we have to apply the activation function. So in this case, I applied sigmoidal function. So what is the sigmoidal function? We know the formula 1 divided by 1 plus e to the power minus x. There are so many activation functions are available. I'll explain. So this is a simple activation function, sigmoidal activation function. So for the input 1, we have to apply. That is called sigmoid of 1. We have to apply. So this answer is 0.731. So this value we have to compare with the desired output. So what is our desired output? 1 is our desired output. So what is our thing? Our weight 1 updation value should be existing weight value plus del W1. So existing weight value means initial weight, whatever given, we have to take as it is. That value should be added with new value del W1. So how to calculate the del W1? We already know the formula. Learning rate multiplied by target minus actual multiplied with the input data. So this formula we know. So as we are taking the first input, we have to take the first input x1. So here what is the target? For the first one, target is given as 1. So we have learning rate is given as 0.1. Learning rate is fixed for all the inputs. It is given as a given in the problem itself. So it is given as a 0.1. So we have to apply learning rate multiplied with target 1 minus actual output. What is our actual output? 0.731. Target minus actual multiplied with the input. Here as we are taking first input, what is our first input? 1, 2, minus 1, 2. It is given. So we have to directly apply. So after multiplication of 0.1 into 1 minus 0.731, we are getting this value. This value should be multiplied with this value. So we are getting the answer of 0.0269, 0.538 minus 0.0269 and 0.538. So this is our updated weight. So hereafter we should use this updated weight only. So initially we applied weight given. After applying with one input data set, our updated weight value is this one. So hereafter we should apply this only. So this is our updated weight one. It is given in blue color. So here now we are taking the second data set with updated weight. So what is updated weight? In the previous slide we calculated. So that is our updated weight. For the value x2 data set 2 and the desired output minus 1, we have to apply this updated weight 1. So first we have to calculate this weighted 1 transpose matrix multiplied with x2. That means this weight 1 multiplied with 2, this weight value 2 multiplied with 1, this third value multiplied with 1, this fourth value multiplied with 1. Because we are having each weight value with corresponding input value, so we can directly multiply and we can directly add. So we will get one answer. For that answer we have to apply the sigmoidal function.